Okay, thank you everyone for joining the TrustedSec webinar on cloud security. We'll get started in about 5 minutes. Okay, thanks everyone for joining the TrustedSec webinar on cloud security, pen testing, and program building. My name is Stephen Marshowitz, Director of Risk, and just wanted to welcome you and give you a little bit of background on why we've been put this presentation together. We've been getting a lot of questions from really both aspects, from technical and from regulatory compliance, on what folks need to do, and there's still a lot of confusion out there around it. Today we'll be going over, again, what are the basics of cloud security, some of the third-party management aspects, implementing a cloud security program. In this virtualized environment, how do we do security testing, and what are the differences between just regular penetration testing? Who's responsible for what are the various cloud models and how you test against them? And then we'll leave room at the end for any questions. So as far as questions go, we have, feel free to ask them along the way. We'll get them to the speakers, and we will answer them all at the end of the conference. We will also be recording this, so if you missed something or wanted to hear it again, we'll have that available to you shortly after the meeting. So let me give you a little background on TrustedSec. Our mission really is to change the security industry for the better. We really want to help our clients, and we have quite a few things that we've done for the industry, including we founded DerbyCon, the second largest hacking conference in America, wrote the de facto standard for pen testing. We've been on the news several times, including today we'll be on the CNBC. So a lot happening within the industry, making sure that we give back. And what we try to do is do the right things right. We're at the forefront of security and what we do. It's really critical right now. Security has gotten much more difficult from both sides, much more complicated. So what we've realized and have known, and what the company was founded on, was really being at that cutting edge, at the forefront of security. We have a very strong research team that is from now around the globe, bringing the best talent to bear. And because of that, we bring that into both our, of course, regular technical assessments, but also our risk assessments. We're one of the few that are able to bring that very technical aspect that is really causing customers a lot of issues today, pulling that into risk assessments, compliance, and really everything we do. And lastly, for those of you who have worked with us, you'll know we're really always trying to be a partner, but even a friend. You see our little logo there, we get the smile. We're always there for you. If you have an incident, pick up the phone anytime. Feel free to call with any questions or anything else that we can do. We always want to be there for you and really help your security program grow. Couple of services I'll just call out. Of course, we're an assessment company, but we've seen a lot in the purple team recently, risk assessments, as well as incident response and preparing for an incident. And coupling those things together has really shown a lot of benefit to the customers, because you're now addressing really all different aspects and all different angles. And that more complicated, that purple team where we're working on the offense and defense, bringing it together. You know, it's not an easy thing to be able to do, but we've seen really some great benefits for our clients in doing so. So with that, let me introduce our speakers today. Our first speaker is Justin Lieblein. He is the PCI practice lead. He has over 20 years experience involved in system administration, software development, information security. He knows more than any man, woman, or child knows about PCI of anyone that I've ever met, and he of course can brings that into all of the information security realms and program management and just general compliance practices in general. Holds a zillion certificates and has really contributed a lot to both TrustedSec and the community. Next speaker we have today is Martin Boss. He is the VP of Consulting Services here at TrustedSec. He's been in security for umpteen years. He was one of the founders of DerbyCon itself, developer of Kali Linux. He's won several hacking competitions over the years. He's a regular speaker at various security conferences around the country, including, of course, DerbyCon, ShmookCon, and many others. And if you've done work with TrustedSec over the last couple of years, you've probably been on the phone with them because he really anchors our calls with clients. So with that, I will kick it off to Justin to get us started.
All right. Thank you, Steve. So first off, just starting up with this, we kind of want to level set on what exactly cloud is. So first thing, perspective is who does what. So, but to level set, let's talk about a little bit of what we're talking about today and narrow our conversation what we're talking about with cloud. So when we're talking about cloud, there's a lot of different models in there. It's one of the most abused words in the, information security, kind of word jungle out there. But one of the things that we're talking about with this is really from an infrastructure as a service or a platform as a service. And what do we mean by that? So infrastructure is when you're launching up your own VMs, launch up your infrastructure, basically responsible for the operating system itself from a stack perspective. From a platform perspective, we're really talking about that the service provider is actually handling that that OS level for yours perspective. And there are a lot of different examples as we're going through this that will actually be a combination of it might be a little bit of infrastructure and platform all in the same type of service. We're going to be not really talking about like the software as a service perspective too much today, even though a lot of these principles will actually blend over to those same concepts and everything. So first off, technology responsibilities. This is kind of a chart that we got from the PCI Council. They actually released cloud computing guidelines, and I thought it was pretty good just to start off with this here. When you're actually engaging with these different types of models and everything, it can actually be a combination of a number of different things, whether it includes, the data you're responsible for, the interfaces, the different programming language, solution stacks, OS. And as you can see, there's different areas of responsibilities per the outsourcing relationship that you have with your cloud provider. And as you can see with infrastructure, you're generally taking on more responsibility as you would than if you have just a software as a service and go to a web portal and handling data like that. Beyond that, there are also security responsibilities into this. So how do you do governance and oversight to this? And even though, the first column is, with GRC, it can be, it's really primary your responsibility, even though you're measuring your cloud security providers as that it is still primarily your responsibility. And we'll get into that a little bit as we're talking about vendor risk management. But other different aspects that would be outsourced would be obviously physical security. You're relying on that provider to do that. But there are a lot of other things that could also be split. There are different providers, like we mentioned, one of the bigger ones is obviously AWS. When you're actually looking at their documentation, they provide actually a pretty good artifact that actually separates on a per service level what exactly they're responsible for and what exactly you should be still responsible for. And there are often times that those are blended. We'll get a good example of patch management. So if you're doing infrastructure as a service and launching up your own VMs, AWS is still responsible for their backend supportive services, their equipment, everything along that lines. But the infrastructure you're launching up, they're not touching that. And they're not supplying updates to it. They're not patching it on a regular basis. That still falls down on your organization's responsibilities with that there. So this is an example. We have a spreadsheet that we work with a lot of different customers. Obviously, that's a little bit PCI focused, but it can actually be blended to any of the control frameworks that you're looking for your cloud service provider to actually be adherent to. We actually help a number of customers actually split out on a per service level of what they're actually engaging their cloud service providers on what they're responsible for versus what is only responsible that, either you're taking on your shoulders solely, or that could be a shared responsibility. And we actually fill out all the details and everything like that why I bring this up is, whether we're helping or you take this on your own initiative, if you get nothing else out of this cloud security program perspective here, the most important thing is to understand clearly where the responsibilities lie from a security perspective. So what is your cloud security provider doing on your behalf versus what you're still responsible for? Are they doing vulnerability management in your infrastructure, or is that on their shoulders? Are they doing access control, on this, or is that still your responsibility? Oftentimes, depending on the service, it's still coming down to your responsibility. And unless you know for sure that they are actually handling it on your behalf, you should assume that you're taking it on your shoulders and look at that from a responsibility matrix then. Okay, so we're going to touch real quick on managing vendors and how to actually appropriately manage vendors. We could turn a whole webinar, in fact, probably multiple webinars on vendor risk management, but I just want to bring up a couple of points on exactly what to do when you're looking at from a cloud security provider. So basics of vendor risk management. Obviously, the first thing you want to do, ensure there's legal obligations around the service. So you're looking at, from a security perspective, adherence to those obligations. So whether that be compliance initiatives like PCI, GDPR, ISO 27001, if that's of interest to you, SOC 1, SOC 2 reports, those things you should actually be obligating them, or it should be in the standard terms and conditions. Often a lot of the big players will include that in their standard terms and conditions, but you need to validate whether that is. If you're going to a smaller provider, make sure that language is in there. When it comes time that you start up a vendor risk management department and you're starting to look for this and you don't have those legal obligations in there, it's going to be a lot harder to collect the evidence you need for this than if you checked from the start whether they're in there or not. Right to audit, obviously, collecting evidence reports, things of that nature. Limited liability, if it is their fault that something was breached or something was mishandled and it's solely on the cloud provider's purview with that, make sure there's a way legally to go back and actually, get reimbursed for those losses and everything. Obviously, the lawyers are going to win out at the end of the day, but making sure that at least legal terms are in there will help you at the end. Measure often and as appropriate with the risk. So one of the things I recommend when people are setting up a vendor risk management is that you need a way to define what that service actually is and what is the risk that they're coming to your organization. And it might not be just from a security risk. It could be from a reliance list, a disaster recovery risk, things of that nature. Those type of inputs into this profile for the vendor will actually help fuel on what you need from them and how often you need to measure from them. So it could be as often as every single year I need to collect something with that. It could be that you need to do an on-site, to actually validate certain perspectives of the program. And it could be that they're really not that important just from a vendor perspective, and it could be every 2 to 3 years, or maybe not even at all. But collecting that information and making those decision points is important to bake into that program. And then finally, artifacts that might actually help you solve that attestation perspective. Obviously, SOC reports, 1, 2, type 2s and everything are helpful. The biggest thing that I recommend to clients, and I've seen it time and time again, especially when we're going into different audits, is that make sure that it's aligning to, again, what you're expecting the responsibility to actually provide. I just actually this week alone got an artifact that was a 2-page summary of a SOC report that was actually just that wasn't a SOC report, yet the client thought it was the actual SOC report. I've had clients where they got the SOC, a SOC 2 report from a client, but they deleted all the testing of the controls out of the report itself, and the client didn't realize that until we dove in to look at it from the evidence perspective. So really look at it from first, aligning what you're expecting from them, and then when you get that documentation, look at it and make sure it aligns up. Some documentation might only be physical security that they're attesting to when they're actually doing managed services on your behalf. So just make sure that aligns up to what you're expecting. So next, we want to talk about a little bit of the technology behind it, a little bit of the architecture, and some of the components you want to include into this, or at least have a good consideration for. So there's really 4 main components, when talking about this. We got architecture and design. So how are you setting this up? How are you making sure that there's different good zones, security configuration management, authentication, key management, and then of course, monitoring it to make sure that, nothing malicious and nefarious is actually happening. So architecture and design. So even though you're up in the cloud, you should still be implementing good security practices, and that includes putting in trust zones or DMZs. So there are certain aspects into the infrastructure that might be more sensitive. Obviously, there's stuff that's going to be exposed publicly to the internet. There should be still a layered approach into this to ensure that if there are vulnerabilities that is exploited, from public facing or through your web application, that you do have some layers of trust into there to hopefully mitigate some of the exposure at the end of that. Enforcing solid access controls, and we're actually going to touch a little bit more on this because that's almost deserving of a section itself. But making sure that, as business justified need to know permissions, they're all as appropriate with that. Lastly, security should be involved from the very beginning. I've talked to a number of different clients, and if your major strategy is moving up to the cloud, or you have a high focus of being in the cloud, it is not unheard of to actually get a security person that is familiar with cloud infrastructure, sometimes even certified for AWS or something along that line nature. It goes so much better when you have somebody that's not only focused on the security perspective, but also understands solidly the technology that's involved with a lot of these cloud service providers. They can give spot-on designs. They can help with automation and build in security into that type of automation. It's awesome. Now, obviously, that's an extra expenditure. Not everybody can afford that, but you should still have a basic concept of, understanding where security should be involved, how the design should actually be, what are the different components used for that. One of the things with architecture and design, as I mentioned before, there are a number of times where blending of infrastructure as a service and platform as a service will happen. Good example of that, if you're using like AWS EC2, launching up VMs of your own, but you're using AWS's RDS, so where they're managing a database instance for you, not necessarily the OS platform, but you have an instance into that. That's kind of that blending of that perspective there. So understanding that fully, and again, the different responsibilities come different per that service there. Secure configuration management, obviously this goes without saying with this. It's a larger perspective on your shoulders if you're running the full OS stack. So if you're managing, CentOS boxes, Red Hat boxes, full Windows boxes, that's up in your cloud environment, this becomes much more important that you can't outsource to your cloud service provider. So the same perspectives happen. If you're doing more of a container-based situation like Docker, there are still considerations that you need to do for configuration management, but a lot of that is contained in the Docker file. That, setting up good architecture when dealing with pods, how that interaction goes, the access level controls with that, all that falls into play with it. Also, too, vulnerability management, patch management. Like I said, if you're dealing with full-blown OSs, this is the same old concept, with Security 101. But even if you're just deploying code up there and using like, Google's App Engine or Lambda for AWS, where you're just uploading code and it's running, there's still considerations into that. You're most likely using some type of OS code or open source code that you're pulling in, third-party packages that do have vulnerabilities. How do you ensure that those packages do not have vulnerabilities? What if they release fixes to vulnerabilities? How are you incorporating them back into it? There's a lot of automation techniques and checking before new code goes into that. Take a use of that as much as possible with it. And always do testing, which Martin will go into later in the slides. And Authentication key management, obviously, big one. First off, everybody should be employing two-factor authentication. Not only is a number of standards actually require it from coming from an untrusted source like the internet with it, but it's just should be a given nowadays. So there's easy ways to implement two-factor authentication, whether you use a tool like Google Authenticator or Microsoft Authenticator, doing things of that nature, or using good providers like Duo or something along that lines. There are a ton of options that you can do it from a good, cheap, if not free perspective. Definitely take use of that for any authentication going into the cloud. With single sign-on, the more you can integrate this, obviously, if you only have a few people into the infrastructure, it might not be as important with this, but this creates more work when you're doing provisioning and deprovisioning. If you can tie it back to some type of ADFS infrastructure or to your local domain for authentication, or if you're a smaller shop and using either Office 365 or G Suites or stuff like that, there are tie-ins to actually get that integrated. Another thing that if you're a little bit bigger and looking to consolidate and you have multiple cloud environments, you could use a cloud security broker that helps out tremendously on unifying all the different authentication points into there, and also integrating some other useful tools with them. A couple of companies that have had issues with this, obviously checking in either credentials or keys into a source code, has led to security issues with it. So never commit any encryption keys or credentials in the code. Obviously, that's a one-on-one, type of thing, but this has led to a number of different security issues. So making sure you have proper credential management. How do you manage that? Do you have it in a repository? Do you have it in, an HSM for some of that? One of the things I recommend to a number of clients is HashiCorp has a tool called Vault. It's a great software kind of base HSM that's great for use. Free to use and everything, pretty solid. They do have enterprise support, but it's one of the things that you can get away with a better security posture without, putting in config files or, hopefully not into the source code itself. So. And monitoring. So you have everything set up correctly, everything's running as you expect. Now, how do you make sure that's actually doing what you think it should be doing? There are a ton of monitoring tools out there. Through some of the stores and everything, you can actually do either behavior aware proxies or certain proxies to monitor some of the platform as a service activity. Pretty much all the cloud providers have logging at their disposal, making sure that you're digesting those logs and putting it into something that you monitor on a 24/7 basis is extremely important. Using MSSPs, to monitor those aspects. There's a ton around there. Obviously, TrustedSec's sister company, Binary Defense, they do a number of that type of activities as well. But just because you have it in the cloud doesn't mean that nothing bad is going to happen. And it's not the cloud provider's responsibility to monitor your infrastructure to that. So making sure that somebody is responsible in that area for your organization. And then finally, actually, one. Monitoring critical changes, not just security issues. So if somebody's adding accounts into your cloud area, get alerted with that. If somebody's launching up new services within your environment, or adding new keys, or if somebody accidentally put your S3 bucket into public instead of private, you should get alerts on that, and there should be a specific change request following a change process with that, and somebody should be notified and alerted to that so that you can respond quickly if it's an issue that you didn't generate or that IT accidentally did or something along that lines. Okay. Now to go into a little bit more details about some of the testing with it and the validation in virtualized environments, here's Martin Voss.
And just one reminder, feel free to ask questions. I know we got a couple of them come in, but just in the chat box or in the question box, and we'll make sure we get to your questions at the end.
All right, great. Thanks, Steve. Like they said, my name is Martin Boss. I head up all the technical teams over here at TrustedSec. And so, now that we've gone into just some of the, compliance and planning and that sort of thing of going to the, quote, cloud, the thing I wanted to touch on a little bit is, security testing in these virtualized environments. So kind of like Justin said, how, security needs to be built in from the beginning, from when you're choosing a cloud provider. And the reason for that is, and I'll go into it a bit more, is that a lot of the stuff is going to be contractual. And so what we see a lot of times is, a company that comes to us and they want to get a lot of their stuff tested. They've put it in the cloud. It's been totally implemented and, everything's working, but they forgot to build pen testing into their contract. And then they all of a sudden, find out that it's not allowed, or they have to get 111 different approvals to to get it to even work. So the things that I'm talking about here, I'm talking about because these are considerations a lot of times that you want to put into place when you're choosing a cloud provider. And I'm I'm totally agnostic. I'm not going to talk about what cloud provider is better than another, because that's totally up to you guys and your organization. However, rest assured that we deal with a lot of them, all of the big players. We also do a lot of dealing with private clouds that people have created and that sort of thing. So the biggest issue for me in a virtualized environment, is trusting that the access controls have been implemented properly and effectively. So we do a lot of security testing against the different types of cloud deployments, platform as a service, infrastructure as a service, all of that kind of thing. But what I don't hear a lot about is pen testing against the actual service providers, right? So that's something that always concerns me, is that. The next thing I like to touch on is that another thing that I see done infrequently is not doing internal testing of your cloud service. So, in the case that it's just a, an application and a database and that kind of thing, it doesn't make a whole lot of sense. An external pen test is generally good enough for that kind of thing. However, if you have a whole lot of operating systems and servers and all of that type of thing up in a cloud facility with, like a VPC, virtual private network and all of that kind of thing, another mistake I see commonly made is not doing internal penetration testing of that environment in particular. And so, what generally happens is the outside gets tested. Everybody says, "Oh, great, the castle wall is amazing. Nobody can get in," and then nobody does the internal testing. But in reality, and I tell this to people on the phone all the time, pen testing your cloud applications or pen testing your network or in the cloud or any of those kind of thing, it's really not unlike a traditional pen test, right? There's no real secret sauce. There's no, we use the same tools, the same tactics, the same procedures. The only thing is that it introduces a lot more things. So, like Justin was talking about containers, right? So containers have recently become, very, very popular. And, there's a lot of talk that the container system will replace the hypervisor. I don't believe that to be true, because all of the, in my opinion, all of the containers run on the same operating system. So if one container is misconfigured, then, all the other applications running on that operating system would be subject to attack, versus a hypervisor where each operating system with an application is running individually. So, and I'll probably touch on that more in just a little bit, but really the main things that come up when security testing in virtualized environments is that there's a lot more rules. There's the terms of service from, sometimes multiple organizations to deal with. Oftentimes the scope can be very, very limited based on what you can and can't test. And you always have to have a lot of different permissions and approvals. Now, most of the big players have started to make this permission process fairly easy, but, 5 years ago, it was very, very difficult. The biggest question is, should we bother? Like, why are we doing pen testing on these cloud applications? We got our contract from, XYZ cloud service provider, and they told us they do all their own penetration testing, right? So we're good. And so this always reminds me of that funny meme. It was going around a few years ago, but it basically said, "What if I told you the cloud is just somebody else's computer?" Right? I mean, that's all it is. So it still needs to be pen tested. We still want to take a look at it. I mean, we're literally moving our data to somebody else's computer in the simplest terms. So I not only want to, I want to do even more pen testing on that than probably my own computer. So the other thing that we see is that when it comes to security, most cloud vendors typically only do what they need to do to achieve compliance. And so, when you sign the contract, they'll show you all their compliance certificates and all of that kind of thing. But how do we know that they went above and beyond, right? We all know there's people out there that do security testing just to check the box on PCI, but we also know that there's a ton of organizations out there that do very, very serious penetration testing. And so, how do we know which one of those this company is? Asking about what type of penetration testing that they do. Most of the big players that I know have their own internal red teams. They got some really, really smart guys on those teams, and they're constantly trying to make those platforms better. But that does not mean that you're exempt from doing penetration testing on your own system, because at the end of the day, it's still your brand on the line. It's still you in trouble if it gets breached. Nobody's gonna say, oh, that bank was running on AWS EC2, so it's AWS's fault. It's still going to be your fault no matter what. So some of the common challenges that I've seen, and I've helped clients with choosing a cloud security vendor, asking the right questions, looking at it on a contractual basis to make sure that they can do this kind of testing, later on. One of the things that I see is they love to give you a whole lot of fancy methodologies and documents. I like to call it paper overload. So it looks like they're doing a whole lot, but if you don't know what all of those documents mean, or if you don't know what the baseline for those tests are, or any of that kind of thing, I totally recommend, like Justin said, bringing in an actual cloud expert that that is an expert in security and knows what these kinds of things mean. The other thing that I love to hear is military grade encryption, or bank level encryption. What does that even mean? Why can't they just say what cipher they're using? So always interesting, the kind of things that they say. Oftentimes I see that they won't allow you to do any internal, external, or web application tests. A lot of times they won't even provide copies of their penetration tests, or attestation letters, or any of that kind of thing. So I was working with a company recently, and they were trying to determine a file sharing service to use, for the cloud. And, at the end of the day, they ended up basing their opinion on, one provider couldn't even provide an attestation letter that their deployment had been penetration tested. And so, that was a huge part of their decision. So basically, I mean, the rest of this presentation is what can you do to make sure that your deployment is secure? So the first thing you want to look at is the permissions, and this is obviously during the contract process and choosing a cloud provider, and these are all really important things to look at. So the first thing that you want to look at is the terms of service and the local laws, because there can be all kinds of legal and technical obstacles there. A lot of cloud providers are in other countries, or potentially in different states where you're not familiar with the laws and that kind of thing. And oftentimes this type of testing can violate the terms of service. So this is one of those situations where you actually have to read the fine print. It is very important on these types of contracts. The other thing that I always ask about is, what's the policy? Typically, they should have a policy. They should have an approval pen test request form. They should have all those kinds of things. And then the next thing that's super, super important, and we'll talk about the couple of different types of cloud deployments a little bit more in depth. Justin brought them up originally, but it's really, really important to know, what type of cloud platform do you have? Is it infrastructure? Is it platform? Is it a blended approach? And looking at what you're responsible for. And the biggest thing that I like to look at is, are any of your databases or any of your servers or any of that kind of stuff going to be multi-tenant? And the reason is that when you deal with multi-tenant databases, multi-tenant applications, all of that kind of thing, they almost always cut penetration testing out, because what can happen is, if something happens to your application during the testing process, it could negatively affect one of the other tenants, and then the cloud provider not only has your company go down and they have to deal with you, they also have 25 other companies go down and have to deal with them. So that's always an issue to bring up as well. The big guys like Amazon and Microsoft, they've been doing this a long time. They got amazing teams. They have all of their authorization request forms online. Google works a little bit different. They say as long as you adhere to their acceptable use policy in terms of service, that you're good. You can do all the testing on them you want. So those are just a couple of things to look at permission-wise when you're going through the contracting process of choosing a cloud provider. This is a little bit about what I was talking about before. Obviously most people are going to be a tenant. The three different types of testing, again, infrastructure as a service, platform as a service, software as a service, those are all tenants basically, and then provider-based penetration tests. That's what I was saying. I would love to see more provider-based penetration tests, so that we can actually look at, the separation controls, on the actual hardware in the cloud environment and all of that sort of thing. So just expanding a little bit on what Justin said, I'll go through these quick. I don't want to totally hash this out, but infrastructure as a service is basically setting up your own network. So you basically have all of the operating systems, all of that stuff is under your control, all of the applications, all of the, either virtualized networking or, whatever else you got going on up there. So typically you can test all the way down to the hypervisor level. I don't believe you're allowed to attack the hypervisor in most IaaS situations. However, that's something that you would want to ask during the contracting process. So basically in this situation, security is all your responsibility. The next thing is the, platform of a service. So this is where it generally gets very, very tricky, right? So, traditionally in this situation, you're given everything you need for an application. You're potentially given a web server to run it on, and you can get everything going. But traditionally, the backend databases in these situations will be shared, or even if it's not shared and you have your own database, it's typically not able to be tested. It's the database itself is typically handled by the cloud provider. And so this is one of those main situations where in these deployments, you can potentially affect other tenants in the deployment if you do this type of testing. So this is where we see the most issues sort of come up when we try to do security testing. And then, it's not really the basis of this software as a service, but it definitely, deserves an honorable mention. There's a lot of, services like that out there, but, typically at best, you can sometimes test your application interface and sometimes you can test the API. But for the most part, the cloud service provider is responsible for all of the security here, the storage, the backend databases. They're definitely not going to allow you to do any SQL injection testing or anything that might negatively affect the databases and all of that kind of thing. They're probably not going to give you test accounts so that you can test, the permissions between the different accounts on the application. And so basically, I mean, the best thing you can do is some authenticated testing, but it's probably not going to get you very far in a SaaS deployment. So 3 types of testing, and this isn't just a TrustedSec. This is pretty common across, application testing. People call it various different, fancy things or whatever, but we just go with the traditional, boring black, gray, and white box. Basically, when we talk about black box testing, it's just against the interface or whatever's internet facing, basically the perimeter of the application with no knowledge whatsoever. A gray box test is probably the most popular for application type stuff. You get a knowledge of an infrastructure, you get a knowledge of all the different user roles and what they do. You get, account credentials so that you can log into the network or the application or, whatever the case may be. And then in a white box test, we would do all of that stuff, but we also do static code analysis in that situation. So that would be a little bit more pertinent for an application, versus looking at, the segmentation on an entire VPC network or something along those lines. But it is very important. There are some pros and cons between the different methodologies. Obviously, the main. I probably should have put cost at the top here, but the main one is generally cost for most people, right? And compliance. If they're just trying to check a box and achieve some compliance, they're usually worried the most about the cost. And so a lot of times they'll go with the black box approach or more of a time limited approach. But this is the same methodology that we use in any kind of application testing, any kind of network testing. Obviously, we want to do as much testing as possible, but there are some trade-offs for the different methodologies. So speed, efficiency, coverage, that kind of thing. So the first thing you want to do in any security testing situation is create a pen testing plan. So that's basically how you're going to execute your test. And so there are some differences in virtualized testing. Here at TrustedSec, we like to separate out testing in the cloud for, between applications and data access, network access, virtualization, compliance. We like to separate all of those things out because they can potentially be owned by different people in a cloud model. The responsibility of each of those things might fall on a different group. Same as with an internal network where you have your database security guys and your sysadmins and your network security guys. So we in the same fashion, we separate all of these things. The number one thing that that we do before testing any type of cloud application or anybody for that matter is understanding the maturity level of the organization. And the reason is that it's not fair to an organization that's just starting out in security or isn't very, very mature or has just hired a security person to basically throw everything but the kitchen sink at them and use all kinds of complex vulnerabilities. And that doesn't do them any good. So for me, the number one thing to do when structuring a pen test plan is understanding our client's maturity level so that we can actually structure a test that will help them and not try to high five, not try to embarrass anybody or give each other high fives or any of that kind of stuff. So once again, here's the different application, the different layers that we look at during cloud testing. We look at the application layer, we look at the network layer, we look at the database layer, and this is all subject to what we are and what we are not allowed to test. And then we look at the hypervisor if we absolutely can. And then something that I didn't put on here, Justin brought it up, is the new container storage type stuff, right? You have Docker containers. There's several other, organizations that are trying to push the container container technology. And so, recently here in the past couple of years, we've been doing a lot of reviews of container configuration files and all of that kind of thing. So that probably should have had an honorable mention on here. So we believe that all of these things should be tested separately and reported separately. And if anybody's curious on a methodology, so we use the penetration testing execution standard for all of our pen tests. And like I said, cloud pen tests aren't much different than normal pen tests. We also, obviously look at the OWASP top 10 and all of those types of things while doing any of our application tests. But the third thing that we refer to when we're looking at a cloud penetration test is this cloud controls matrix here. You can see from Cloud Security Alliance. It's a extremely large, robust spreadsheet that allows you to sort of audit your own instance and look at, based on the instance, based on the deployment, it allows you to look at all of the things that you're potentially responsible for. So most of the common cloud application issues that we look into is access management, via credentials or API. A lot of times we see, APIs fall apart after X number of attempts. One of the probably, sadly, the biggest thing that we still see is single factor authentication to some of these things. The other things that we look at is VM segmentation, not working properly, I guess, but VM segmentation not working properly. And then from a compliance perspective, oftentimes we see the encryption is not compliant with the new regulations. Basically what happens is, an application can't do the same encryption as the backend database, so that, the developers downgrade it to the lowest encryption that they can get working and that kind of thing. So, and there's a lot of issues around, network protocols and communications and, SMB replay attacks are, still alive and well out in the wild. So the encryption between application databases and other devices on the network has become increasingly more important. And then anybody that watches the news probably knows that misconfigured AWS S3 buckets are a huge deal. There's been a lot of record exposures based on those types of things. There's a lot of great tools out there for finding these AWS S3 buckets. And then the one that, that Justin brought up that I probably should have put on here was also, application keys out in your source code. So once again, unless you've been living under a rock, you've seen a lot of the stuff on the news about people's keys being found in GitHub committed code and that kind of thing. So we still see that all of the time. So, I encourage people to totally challenge your cloud service provider. I mean, they want your business. There's a lot of people out there. I mean, you don't have to take the first cloud service provider that gives you a good deal. Here are some things that I, like to sort of get some answers to when negotiating in this process. And the number one, is back to, where is my data? Where is it being stored? Is it in a US data center? Is it in a, a Syrian data center? Is it, is it spread out across 8 data centers? So that is important to me. Where is my data? Do they have any denial of service mitigation? So, if I'm paying all the money to host my stuff in the cloud, I don't want to have to pay the money for denial of service mitigation or some other service like that, right? That should be part of the package with your cloud service provider, in my opinion. Asked to see their disaster recovery plan, their redundancy plan. One of the reasons for going to the cloud for a lot of people is for uptime. They want, the cloud service providers will tout a better uptime. So, ask them to prove that. Let them, tell them that you want to see your plan, their plan. The next big thing for me is exportable data. I have seen people get completely locked into certain cloud service providers because their data is formatted in a format that only works with one single cloud service provider. So they basically hold your data hostage because you can't export it and move to another cloud service provider if you're unhappy with them. So that's a really big thing that I tell people to ask about. Third-party security testing, what we've been talking about the whole time here, make sure it's allowed, tell them, it's great that you guys do your own pen testing. I understand that totally, but I trust, XYZ company over here that we've been working with them for years. We'd like to let them do a little bit of testing. And then make sure to talk about what's out of scope. There's a lot of types of testing with some of these vendors that will be out of scope. And so while it's not necessary to cause denial of service tests, we don't even really do that. But SQL injection is still alive and well and needs to be tested for. I think we find a couple of them a week, across my 50 or so consultants. So SQL injection, is getting better, but it's still an issue. So you definitely want to be testing for that type of thing. And then, most of these contracts are boilerplate. Ask them if you can customize it. Ask them if you can build some of this stuff in there. If they want your business, they're going to let you do that. So, the cloud offers a ton of benefits. I talked about a bunch of them. Most of them rely under functionality and cost. It's the adage of it costs a lot of money to keep my own network up. Let somebody else worry about it. That way they can be responsible for the uptime and I don't have to. They can be responsible for hiring the professionals and I don't have to have as many. Totally understand the benefits of the cloud. There's a lot of great cloud services out there nowadays. It's come a long way in the last 5-10 years from where it was. You don't hear all the jokes that you used to about it. And, with the upgraded authentication and all of the new services, it's come a long way. But it definitely still, introduces new risk. I've said it 5 times, but your data is gone. Your data goes outside the company perimeter and you're entrusting somebody else, to watch over it. And even in an infrastructure as a service situation, you can do everything you can to protect your data. But the actual physical hardware is still out of your control. There's still a lot of things that are out of your control, and it's okay to accept that risk, right? Running a network is all about accepting risk, and so but what I say is that it's impossible to accept a risk if you don't know what it is. So pen test everything.
Okay, great. Thank you, Martin. And we have, again, still more time for questions, but we have a couple of them rolling in. And the first one is for Justin. What partial responsibility for PCI? What is that? How do you know what that means?
Yeah, so when we say partial from a PCI perspective, typically you're looking at a control like having good secure configuration baselines, like requirement 12.4 or 2.4. In that, it means that, if you're looking at a cloud service provider in their core infrastructure, they need to have good security baselines for their OSs. But when you're launching up an infrastructure piece and launching up full VMs, you need to have the same for your infrastructure. So you can't forget your service provider actually doing that, but also too, that doesn't escape you from doing it in the same vein as your infrastructure there. So that's where it would fall down as partial.
Would those be some of the biggest issues with cloud and regulatory compliance?
Most of the times it's not necessarily that's the biggest issue. Like I had mentioned before, like really understanding who does what is the biggest gap when I come down and actually look at how they're measuring their service providers. Oftentimes clients don't have a good understanding of what they're doing for their compliance perspective and what they still should be doing. For example, looking at they're hosting different e-commerce environments, and they assume they're doing, vulnerability scans, AVS scans, approved scanning vendor scans for PCI. But when they double checking on that, they weren't doing it, and neither were them. And obviously, there's a gap in the compliance at that point there. So really having a clear understanding of who does what is the most critical thing, and then you can start aligning all the controls and responsibilities from there. So.
Okay, great, thanks. For Martin, Martin, do you have to specify cloud testing, or is that part of a typical pen test? And then who creates the pen testing plan? Is that TrustedSec or is that the client?
So great question. So for us, on an external pen test, it doesn't really matter to us whether the IPs are cloud IPs or if they're IPs hosted by by you guys. So it doesn't really come into play so much on an external pen test, but it does come into a little bit more play when we're doing application testing, because that's where you start to need the proper permissions and all of that kind of thing. AWS and Microsoft, they just want you to fill out a paper and say, hey, we're going to be doing some testing. And oftentimes we just have clients send those paper to us and we fill them out for them. I do several of them a week. And so for us, it doesn't really matter, but in an application testing situation, yes, it would matter, because just to make sure that we get all the proper permissions in place and we know what is and what isn't out of scope. The pen testing plan is generally created by us. And so oftentimes a lot of that is done through scoping with me personally, or with one of my practice leads from a particular organization. But anybody that's been on the phone with me knows that I ask a lot of questions about where the maturity of your security program is, so that we can tailor a test that that actually helps you.
For an MSSP relaunching or rebranding their pen testing essentially from scratch, what is your number one recommendation? Certain software, certain must-have skills from staff. We deal with a lot of compliance, but have always outsourced pen testing until recently. So the question is, what's the number one recommendation for an MSSP?
I guess I'm assuming that's for me, but the number one thing to be talking about yourselves from a pen testing perspective is the fact that you know the difference between real pen testing and vulnerability scanning, that you know the difference between manual testing and automated testing, that you actually have people that know how to manually test networks and your test isn't based on automated tools. The landscape of penetration testing is changing rapidly. It's getting a lot harder. Automated tools that worked 5 years ago, aren't working. EDR and AV solutions, any kind of endpoint protections are shutting down all of those types of tools. So if you don't have people that pen test manually, the service isn't going to get very far.
Yep. And Martin, just to jump onto that, I think the number one thing when you're rolling your own kind of penetration testing team is the capabilities of your team. So making sure you're investing in good training, good skill sets, and like you mentioned, like making sure they know the difference between actual pen tests and just running a scan with that. One of the components of that question was tools and testing. Martin, correct me if I'm wrong, but most of our tools are actually open source and free to use out there and everything. So really, It's not necessarily the investment in that, it's the capabilities of the person performing it.
Okay, great. Another one, Justin. We're a service provider for PCI. Mm-hmm. How do we know who checks what and who does what?
Yep. So one of the things I recommend is working with your QSA on that. It's actually interesting when you're going through a service provider, either ROC or SAQ, you actually have a little bit more leeway than what you would have than a merchant. For example, you can actually say, we don't do this for merchants, that's all up to you, and we're not going to certify ourselves for doing that. Now, you might get some pushback when merchants come to you and say, we expect you to do this for us. But at the same token, you're not as obligated from a PCI perspective on certain aspects. I've been working with some, cloud providers that, they, are working in certain security offerings into their cloud solution, so that kind of take the onus off some of their clients and everything. And they can certainly do that, or they can leave it to the merchants with that. When you're talking about, formally deciding, what bucket goes where, which ones are shared, it's not required from the service provider perspective to provide this, but I often recommend that as a value add to your customers, to provide a list to your customers to say, here's what we're doing on a per service level, similar to the artifact that I showed earlier in the slide deck. Here's what we're providing for you from a compliance perspective. Here's what we're not, and here's what you're still responsible for. And there's certain aspects that could be a shared perspective with that. And that's really valuable because that's actually an artifact straight required from PCI in requirement 12.8. So that's a really valuable situation, and it puts it very clear what you're taking on your shoulders and what you're still putting on the merchant's shoulders from an obligation perspective.
Okay, not sure who this one's for, but are there low-cost options for multi-factor authentication, and specifically with Exchange 2010?
Yeah, so I'll take this one first, Martin. So there's absolutely low-cost options. Like I mentioned before, Google Authenticator is free to use. You can get it integrated. From a provider perspective, I've done personally some work with like Duo, and you can get that integrated with Active Directory, and Exchange 2010 would be right there into that to provide authentication into it. Obviously, it comes down to what service you're talking about. If you're talking about authentication from multi-factor from email clients, or you're talking about the web client with that, there's different authentication considerations. But there's absolutely low cost things. Even from a hardware perspective, you could utilize YubiKeys, into that, and I'm sure there's a way to actually get that integrated with it. So.
Okay, great. One more here. PCI requirement 11.3.4.1, Justin. Additional requirement for service providers only if segmentation is used.
Yep.
Confirm PCI DSS scope by performing pen testing on segmentation controls. Can this be done with Nmap?
Maybe. So typically what we see for proving that there's segmentation controls into that is a combination of ACL reviews, which is already required twice a year, and looking at basically availability of ports and services to confirm that through the different segments. Now keep in mind, PCI requires that you test each of those segments. So if you have a wireless segment that may have different ACLs into the cardholder data environment, the CDE, and a general network and maybe a phone system, you need to prove that there's segmentation controls between all of those. So making sure that there are good things along that lines. But it goes beyond that too. Good segmentation controls could also mean making sure some of the other controls are in place. So I could have it fully locked down except for port 22 SSH into that. But if I have admin as credentials into that, that's not necessarily good segmentation controls into that. So there's a lot of other components that could go into whether there's good segmentation controls into there as well.
Great. Okay, one last one. Martin, you mentioned about internal testing in the cloud. How would one go about doing that? You can't plug in, for example.
So there's a variety of different ways to do that, but traditionally what we do is, get some sort of access into an application that it would allow us to pivot in there. It's sort of like a second step, right? So, say, for example, you spend week one, pen testing the application itself, but behind the application is a whole bunch of, databases and middleware and all that kind of stuff. So, at some point, doing something on the application to, launch yourself into the environment, or giving yourself some type of shell on, one of the operating systems in the environment. Even with AWS, just getting some test SSH keys to see what can be done inside the environment. a lot of times, like Justin said, you still want to have a DMZ, for example, in any kind of, even in a cloud environment. So oftentimes we get dumped in the DMZ as a very popular form of testing to say, because more and more times people are understanding that, their first line of defense is most likely always going to break down. So testing each level of defense after that is becoming increasingly more important. So, accepting the fact that, somebody is going to pop this application at some point. So once they're in the DMZ, what can they do after that? And so we have a variety of different, shells, tools, and software to, simulate any type of implant in those situations.
Excellent. Okay, well, thank you very much. Thank you to Justin and Martin. Really appreciate sharing your knowledge today. That was very informative. Again, I think it answered a lot of questions for folks, and we'll help those going forward. As always, this recording will be available. It will be sent to you for anyone that signed up, but also available on our website, so definitely check that out. And then also look for more webinars coming forward for next year. Quite a few topics coming up, so should be really interesting. Thanks again for joining us, and we look forward to talking to you again.